It is. Okay. And all right, so is it working for people? Whoever's trying it? Is that a yes? Okay. Well, I'll keep cooking. Yeah, it might be slightly delayed. I don't know what it'll end up being on your end, but we'll give it a shot and see what happens. Because if this ends up being a good option for people in the back, we can always do this every class. But because I know these monitors are not the easiest to see. We're getting a new 75-inch we're going to put there in the middle as well. We already have it if you're have any classes of 118. We have two 75 inches in there. And then we're going to have another one in the middle of 120. Okay. So last time we were talking about method overriding or method overloading, and we talked about a couple of things here where so we kind of gave some context to the idea of these underscore methods. So we have several underscore methods that are built into Python, and really what we're getting here is some insight into how Python works under the hood. And what I mean by that is you know, we already see it a little bit when we see us passing the word self around all those functions. We're kind of seeing, it's like you pop the hood of your car and you're seeing all the wires and cables and, you know, engine parts and stuff like that in there. And, you know, most of us, we don't know what half that stuff does, but we know it's a pretty integral part. Okay, but when we look at it, we're kind of seeing how Python has bolted together object-orientedness. Now, that may or may not be overly interesting to us at this point. But there's a couple of aspects of that we can take advantage of. Okay, so a few things are just requirements, right? A few things are like, hey, look, you pass the word self around to all your functions because that's how Python gets access to, that's how an object gets access to itself, is it takes itself as a parameter so it can talk to itself. It's something that, you know, they're getting from the psych ward, but it's a thing. All right, so it's almost like passing around a walkie-talkie to themselves, so they're talking to themselves. But that's a requirement for us. But now we start seeing, you know, up to this point, we were making our constructors, right? This underscore init thing, and we've said, okay, well, the constructor's job is to build the initial state of our object. Fine. But up to that point, you know, our last class, we said, it has to be called underscore init . Just because. All right? You got to call it that. Just do it. Now we're kind of recognizing this idea that there's several methods in Python that follow this pattern of underscore something underscore. One of them is the constructor, where the something is init. Another one we talked about last time, which is going to be a pretty important one, is the str, the string one. All right, because if we create an object, does anyone remember? Well, I'm here. If we create an object and just print it out directly, we're going to get a crazy looking memory address thing, right? Now, if we override that underscore str, we get to change what will happen if we print out that object. Okay, and I actually want to review that for a few minutes because this is a pretty important concept. Not just the overriding the string thing, but understanding what we get when we create an instance of an object. So let me open up our code here. I don't remember what we wrote last time, but I'll just work with whatever we have. All right, we have this person thing. I'm just going to rename str to str2, just so this guy doesn't do his job right now. Okay, so we have a useless str2 function. So I went ahead down here and I created a couple of persons. And then I printed those two persons. I'm going to get rid of the less than, greater than. Those were just some other override methods we did. Now, this is a plain Jane object. This could be a person. This could be a dice. This could be a cat, a dog, whatever we invented as our own objects. It could also be stuff built into Python, which we haven't messed with those things too much yet, but there are object types built into Python as well. All right, but whenever we create something that is an instance of an object, this is our way. So effectively, what would you say is happening right here? When I say P is equal to person, like this, what's actually happening behind the scenes? If you had to describe that to me, what might you say? What function's getting called magically behind the scenes? Underscore, underscore what? Oh, come on, people. It hasn't been that long of a break. And it, right? Okay, so this is how I call the person constructor. My person constructor takes in two parameters, a name and an age. I'm passing this guy a name and an age. I'm passing this guy a name and an age. So the syntax in Python for creating instances of objects is by saying the object name followed by an opening parenthesis, followed by whatever parameters it takes, followed by a closing parameter or parenthesis. What's magically happening behind the scenes is this underscore underscore init method is being called. That's what's happening. And this stuff inside of that is what is happening as part of the construction or the initialization of this person. All right, that makes sense? So this is me defining what that constructor is. This is me using that constructor. All right, now, so I've created two persons. Now I'm gonna go out, I'm gonna try to print out, now I want you to see the difference here. I'm gonna print out P, and then I'm gonna print out P dot name. Okay, what's gonna print out when I say print out P? Reminder here, I did rename the string function to string2. So I'm no longer, in fact, here. Just nothing up my sleeve. What's going to print out right here? Dave 39? Okay. Somebody give me a, tell me why he's wrong. Let's go that route. What is P? Tell me everything you know about P. You probably should have named it a different variable. That's going on the soundboard. All right, go ahead.
It's just like an instance of the object.
Okay, so at the most basic level, P is a variable. Variables hold values. The kind of value that this variable holds is a memory address. It holds a pointer to where my actual instance of person was constructed in memory. All right, and so it's holding a memory address, and when I print it, it's calling the default version of the string class. Or I'm sorry, the default version of the underscore underscore string function. And that default version prints out the memory address looking thing of that guy. Okay, so whenever I print a variable, variables resolve to their value. The value that P holds is a person. Okay, and that person, when it's resolved, resolves to the result of its underscore underscore str underscore underscore when I'm using it with print. Now let me kind of put that in writing a little bit. It's an important distinction for us to, when we think about, you know, I've kind of been harping most of the semester since we started the coding stuff on this idea of, as you walk through code, consider what variables resolve to, what, you know, what value they ultimately boil down to, because sometimes things aren't what they initially seem at a glance. Okay, so I'm going to just talk about the print function for a second. Now, we've used the print function for a long time, right? Now, the print function, there's multiple versions of this print function that we don't necessarily see, but I'll just say here, multiple versions of this function that know how to print different kinds of things. All right. Now, I'm going to just introduce a term to you. Maybe you even heard me say it before because it's kind of a funny, fun buzzword. I won't test you on this, but it's something that sometimes comes up on the CS get-together quiz thing. But we have this word called polymorphism. And polymorphism, as it relates to computer programming, is having more than one method with the same name, but a different number / type of parameters. Let's say number and or type. And the type thing is a little bit loosey-goosey when it comes to Python because it's a loosely typed language, pun intended. But you know, generally speaking, polymorphism says we have a bunch of functions that have the same name, but they happen to take different parameters. All right. So in this case, we have a version of the print function that knows how to print an int. We have a version that knows how to print a double. We have a version that knows how to print a string, so on and so forth. So all the different primitive types that we work with, the print function knows how to print, correct? There is a version for ints, chars, strings, doubles, booleans, etc. Then there is a version for objects. All right, so this is kind of our catch-all. This is a catch-all for anything that isn't one of the other types, but instead is a user-defined object, or probably a user-defined object. Could be built into the language as well. And what print does for that is it displays the result of the __str function. All right. So the makers of Python, when they wrote this print function, they wrote 7, 8, 9, 10, however many versions of types they decided they needed to have it work for, numeric types, Boolean types, floating point types, yada, yada, yada. Then they had a catch-all that said, if it's not one of those, and instead it's just some kind of object, what we're going to do is we'll just call that object's __str__ function. And we've proven to ourselves over here, we know that that function always exists. We come back to our code here. I did not write that __str function in here, correct? But I still have it. There's a little, I'm not going to go too far into this yet, but we're going to be talking about inheritance maybe next class or the class after that. There's a little invisible thing here where a person inherits from the generic object of Python, where generic objects have an init method, generic objects have an str method, so on and so forth. Okay, and the generic str method returns the string representation of a memory address. So if we don't do anything extra, that's what we get. If we're an object, we get the default one that just says, look, print, you're going to try to print this thing with the print function. This is what will happen if you do so. Okay? Now, soon we're going to create different kinds of persons when we introduce inheritance. So we'll have a person that is like a ninja and a person that's a wizard and stuff like that, where, you know, they are instances of different things. And we're going to talk about that. We'll start talking about that today a little bit. But when we don't do anything special, we don't think about creating a hierarchy of classes, and we just, at this point, we've just been thinking we've created persons, we've created dice, things like that. There's a little invisible syntax here that says a person is an instance of a generic object. And then this is how he becomes a little more than that. This is how we've differentiated our person from the generic object. All right, that makes sense? So when I print out P here, I'm calling the version of print that knows how to print an object, because that's the kind of value that lives inside of P. P is a memory address that points to an object. What will it do for that object? It displays the result of the underscore underscore str underscore underscore function. And the default function shows a memory address. What will this line do? Print p.name. Oh, what's P? P is an object. This is specifically saying I want the name of that object. That's this variable right here. And we built this in terms of passing in a name for Dave for P. So this will print out Dave. So there is printing out P. That's a person object, memory addressy looking thingy. And here is P's name. Make sense? Now, if we say, hey, I don't want to use the default one, and I say def underscore underscore str underscore underscore self, and I just return the string LOL, I change nothing else in the code. Again, reminding ourselves from the slide, what does the print function do for objects? It displays the result of the underscore underscore str underscore underscore function. Well, now I've written my own version of the underscore underscore str underscore underscore function, and this guy returns the string LOL. There's our LOL. See how that's working? Go ahead. No. Yeah, so let's go back to this slide here, because this slide, I think, says it accurately. So we're dealing with this last part here. So P is an instance of person. It's a user-defined object, something we wrote. So if we're printing out one of those guys, not one of those guys' attributes, like p.name says, give me the name attribute of that object. That's where we're getting the actual string or the actual number or whatever we stored inside of self.name or self.age or that kind of stuff. But in this case, if I'm saying I want the print function to print the value of this object, whatever that means, what print will do by default is it will call that object's string function. It's not a variable. This is a function that belongs to that object. And even if you didn't write that function, that object got that function from his parent, which is the generic object in our current case, which we had nothing to do with. It's part of how Python implements object-orientedness. There had to be a beginning, the most generic version of an object that only is a memory address and a string function and a couple of things like that. And then it could become more when we defined a person. All right, so all print is doing is it's calling that object's underscore underscore str function like that. And we can see that in action. If I just come down here real quick. So I'm going to print P. And on the very next line, I'm going to print P dot underscore underscore str underscore underscore like that. Let me go run this real quick. You see we get LOL twice. So So let's look at those first two lines and unpack them a little bit. So in this case, I'm printing P, which is an object. And this guy is calling, P's underscore underscore string underscore underscore method. In this case, I am calling P's underscore underscore string underscore underscore method. What kind of value, I'll come to you in a second. What kind of value does our string or underscore underscore string method return? What kind of value is LOL? Cat, dog, number, string. String. All right, so that's a string. So what's actually happening down here is even though these two lines produce the same result, we're actually seeing two different versions of the print function. This first version of the print function, this is that polymorphism stuff we were talking about. This first version of the print function, it is calling that object's underscore underscore str underscore underscore function. The second version of the print function is no different than me printing out LOL. This is the version of print that knows how to print a string. Because this guy right here, even though it looks kind of crazy, ultimately boils down to the string LOL. Does that make sense? Yeah, so it's not accurate to call it a default value. That's where I kind of got hung up on everything. It maybe acts that way. So it's not inaccurate to think about it like that. I guess at some level it is the default value, but what it really is the result of the underscore underscore str underscore underscore function for that object. I think that is, well, it's definitely significantly more accurate than default value. But if you want to think about the string result as the default value, that's okay. Just make sure you're kind of following through it in your head. Go ahead.
So essentially, if the value is, sorry, the class is properly defined in terms of that.
Well, not, I think you're saying the right thing. You're saying if we don't define this, if I don't write the string function like this, it'll return the invisible string function that it got from its parent, which is a generic object, which we've seen by evidence returns a memory addressy looking thing. That's what the default is. So any way you cut it, Python's going to recognize that, oh, that guy right there is a generic object. Therefore, I'm going to call his underscore underscore str underscore underscore function and let the chips fall where they may. I'm calling that function. That function will return a string. Now we know it exists because it came from object. So at the very least, it's that generic one that just returns the memory address. But hey, if the user defined a more local one that did something more colorful, fine. But I'm calling that function, and that's what's going to print. Make sense? Okay. But it is an interesting understanding thing here that even though these two lines boil down to the same result in terms of what appeared on the screen, they're actually two different versions of the print function. The first one is taking an object and calling its string function. The second one is calling a function which returns a string and just printing that string. So the second one knows how to display a string. The first one knows how to display an object. Two different versions of that function. That make sense? From our perspective, as a user of these things, it doesn't necessarily matter how it's working under the hood. So the lesson we should take away from this for the applied version of programming with Python would be, if you make your own user-defined objects and you want to print those objects out and you want it to show something other than crazy memory address, write your own string method. Write your own underscore underscore str underscore underscore method to override the one you got from your parent. All right? Or don't call the print method. Or don't try to print it directly. You can still use the values. So like right down here, I mean, I didn't have to define a string method here in order to say print p.name. Because p.name resolves to a value. And the name for a person is a string. So this is the version of print that knows how to print a string. Has nothing to do with the underscore string function. Make sense? Okay, so some interesting connection stuff there. Now, what I want to do is I want to talk about a important operator. It's in the book. I'm going to give you a reading assignment tonight from the book. Let's see. Yeah, this was the operator overloading stuff we talked about last time. This is where we're going here pretty soon with inheritance. We'll also do some file IO stuff. I think it's called isinstance is the name of the function. I'm like 98% sure it's called isinstance. Oh, I passed it. It was here? Oh, thank you. Yeah, so let me show you how this guy works. Let's put it in our notes first. All right, so I've mentioned this, so you've heard me use this phrase that we have an instance of person or an instance of dice, right? Okay, so what is an instance as a starting point? All right, so if you go to the cafeteria and you grab 2 forks, you have 2 instances of the fork class. Okay, you have 2 actually created fork objects. You got this one and you got this one. If you bend the one on the left, the one on the right does not bend. That would be a cool trick, right? It's the magician thing, he does that thing. Okay, but generally speaking, I have 2 separate instances, 2 separate objects of that type. All right, so this is a created object of a specific type. So I'll use our little example here just as a reminder. If I grab 2 forks from the calf, I could say I have 2 instances of the fork class. That make sense? That's what an instance is. Now, if I held up that fork and I said, is this a spoon? What would you all say? Not a spoon. Okay, like, no, that's not a spoon. And then if I asked you, is this a fork? You would say, yes, that's a fork. So we have a Boolean operator. It's actually a function in Python called isinstance that takes in a value and a class to compare. Say something like that. All right, so for instance, if I say person P is equal to, oh, sorry, no types in this language. If I say P is equal to person Dave 39 or whatever I put for the age, all right, and then I say is instance P, that's my value, person, this guy would boil down to true. P is an instance of person. But if I said is instance P int, this would boil down to false. P is not an int. P is a person. That makes sense? So I have the ability here to ask a question. Whether if I have an object in my hand, you know, I can ask what kind of object is this? All right, so that allows us to do the human version of, we reach into a bag, we pull, let's say it's a bag of, change, quarters, dimes, nickels, pennies, blah, blah, blah. You pull something out, all right? And then you hold it up and you say, is this an instance of a quarter? Yes or no. Is it an instance of a dime? Yes or no, so on and so forth. All right, that makes sense? Go ahead. Well, and we did that right here. P holds a value, and that value is an instance of the person class.
Yeah.
Then we can ask the question, if P is an instance of person, if that boils down to true, I can do something. I can ask questions related to that. Okay, and let me show you an example of this. Actually, let's use we get out at 55, so we get 10 minutes? Okay, that's plenty of time. Let's create a couple of more objects real quick. This will ramp us up for inheritance discussion next class. Okay, but I'm going to create a class called quarter. And this is going to be init. Define that. Self. And then we're going to say self.value is equal to 25. And then we'll go ahead, we'll actually define our, we'll just leave it like this. Let's keep it simple. So my class quarter, here's my constructor. It just sets the value of that guy to 25. So now I'm going to create a class called dime. His value would be 10. This is going to be a good use of inheritance when we get to it. But for right now, these are just separate classes. They just look real similar to each other. Nickel and penny. All right, so I have 4 different new object types that I just built. All right, so now what I want to do is I want to go through and I want to create a list. I want to create a coins is going to be an empty list here. All right, and what I want to do is I want to go ahead and I want to fill up this guy with random coins. And we're going to use our random number generator. What was that? Randint? Is that what it was? I had to import. Okay, I imported. Oh, I can just grab it from Dice here. Where's the roll? Yeah, Randint 1 to number of sides. Okay. Just going to steal this real quick. All right. So what I'm going to do is I'm going to go ahead and generate, I don't know, 50 coins. So for I in range 0 to 50, I'm going to do something. So I'm going to do something 50 times. Here, I'll bounce that up on the screen a little bit. Okay, what am I going to do each time? I'm going to create either a quarter, a dime, a nickel, or a penny, and add it to my list. Okay, so if, well, let's go ahead and say val is equal to randint 0 to 4. And let's see, randint is inclusive. I believe so. So this will actually be 0 to 3. So it'll give me either a 0, a 1, a 2, or a 3. 4 different types. I'm going to say if it gives me a 0, I'm going to build a quarter. If it gives me a 1, I'm going to build a dime. If it gives me a 2, I'm going to build a nickel. If it gives me a 3, I'm going to build a penny. All right? So I have my value. If val is equal to a 0, I'll say coins dot append, and I'm going to build a quarter. LF, whatever, val is equal to 1, coins dot append a dime. LF, if it's a 2, we'll make a nickel. And then I'll be explicit here. I said else if it's a 3, we'll build a penny, but we could also just say else. It must be a penny. So in fact, I'll actually just do that. That's probably the more correct way of writing it. Else, build a penny. All right, so 50 times through, I'm going to do something 50 times. What am I doing each time? I'm going to give myself a random number between 0 and 3. If I happen to get a 0, I'm building a quarter and adding it to my value. If I happen to get a 1, I'm building a dime. If I happen to get a 2, I'm building a nickel. If I happen to get anything else, my only other option would be a 3, I'm going to build a penny. And what am I doing with those? I'm adding it to my collection of coins. So when all is said and done here, if I go after this for loop and I print out coins, it's going to give me a list of my various types of coins, right? I have a big collection of quarters, dimes, nickels, pennies. All right, so here's a dime, here's a penny, quarter, blah, blah, blah. So we got a whole bunch of different types of things, right? Now, I might be interested in counting how many of each I got. That makes sense? And I could use my isinstance of, or my isinstance thing to do that. So now what I'm going to do is I'm going to create 4 variables. I'm going to create quarters, start that off at 0. I'm going to create dimes, start that off at 0. I'm going to create nickels, start that off at 0. And I'll create pennies. I'll start that off at 0. And now what I want to do is I want to go through all of the objects in my collection, my coin collection. And if it's a quarter, I'll add 1 to quarter. If it's a dime, I'll add 1 to dime, and so on and so forth, okay? And we'll use our other version of the for loop here just to practice with that. So I'll say for coin in coins. Okay, so each time through, coin will be equal to the next coin in my collection of coins. I mean, I could have called this for LOL in coins, and then I just have a variable called LOL. But if I have a collection of coins, I reach in and grab 1. What do I have? I have a coin, single coin. So for coin in coins, I'll ask a question. If isinstance coin quarter, quarters, I'll introduce a new operator. Plus equals 1. I think the book has already shown that one, hasn't it? Yeah. So that's equal to saying quarters equals quarters plus 1. Else, or elif, right, isinstance coin dime, dimes, I'll also say dimes plus plus, as the book introduced that. Oh, is that work could only Python 2.6? Well, no, it works in all C languages. It definitely works in Python 2.6, but we won't screw with it right now. I'll just type it. Elif isinstance coin nickel, nickels plus equals 1. Elif isinstance coin penny, pennies plus equals 1. And then when all is said and done, we'll go ahead and print a formatted string. So we'll print an F string, and we'll say quarters quarters. I'll kick it down a line with a \n. Dimes, dimes, nickels, nickels, pennies, pennies. Is instance, so is that what it was called? Oh, it's a lowercase I. Is instance like this. So we rolled the dice. We got 17 quarters, 10 dimes, 13 nickels, 10 pennies. Roll the dice again. We get a different number. All right. That kind of makes sense how the is instance allows us to ask if an object is of a certain type. Go ahead.
That is, it boils down to
True or false. It's a Boolean expression.
So when you're saying if, and it comes down to true, it'll do it.
Yeah, that goes back to, I'll just say this real quick. That goes back to the same thing as we said before, where it's redundant. If that boils down to true, is what that says. Because if this is true, then we're asking, is true equal to true? It's true that true is equal to true. All right, so I'm going to give you a couple of sections from the book to read. What have we read up to this point? I know we went through constructors. I think we're done with that. I'm going to skip. I'm going to skip exceptions and modules here. We've kind of used them, but I want to get into inheritance. So why don't we look at 13.1 to 13.3? So that'll introduce inheritance to you. Then we'll specifically talk about it next class and look at some examples. All right, so the usual assignment, I'll put it up, but do those three things, give me a couple of paragraphs about what you learned, and then do all the interactive stuff, and I'll be able to see that you completed the interactive stuff. So keep in mind that when you write something and say, I did this, I can also go into Zybooks and see that you did it under your account on there. So I don't grade the accuracy of it, but I can see that you did it. So go ahead. Yeah, don't worry about it. Yeah. I mean, I'm not looking at, did you, only 97% of it. It's pretty clear whether somebody went through the motions and, it ends up being a 73% or something, or, did this person not even go to the Zybooks website and just saw what the titles were and wrote something. All right, I will see everybody on today, Wednesday. I'll see you on Friday. Make sure you do check out Slack. I put a thing in general about a hackathon thing here on campus next Thursday that I strongly, strongly, strongly encourage all of you to take advantage of. I will give a homework assignment on Wednesday due Friday next week, and you will have the option to either do that homework assignment or attend the hackathon for credit. Okay, so I realize you may not be able to make it, but the Commons from downtown places a lot of interns. So this would be something that if you're able to make it, because it's some good networking, and it's only 3 hours long, and it's here on campus. All right, let me stop the recording real quick so I don't forget. Wait.